Calling something a rational expression is just a fancy way of describing a fraction that has variables in it. And so, just like with ordinary fractions, we've always got to simplify them as best as we can. So in the first example, it's as close to reducing a regular fraction or some of the other expressions that we've looked at as we're going to see, because there's no addition or subtraction. So in this case, I'm just going to reduce the numbers. I'm going to find something that divides evenly into both 18 and 60, which hopefully we recognize as being 6. So I can replace the 18 with 3 and the 60 with 10. Then with those variables, I've got an a squared in the top, a y to the 5th on the bottom. There's no overlap between those, so I'm just going to leave my answer as 3a squared over 10y to the 5th. So there isn't all that much that we can do with that question. In the second example, we might be tempted to try to reduce the x squareds here because we have an x squared on the top and bottom, maybe replace those with 1s. Replace those x's with 1s as well, and then maybe wipe out the 12s. This is a catastrophe. We cannot cross-cancel or reduce things that are connected by addition and subtraction. We can only connect things that are connected to each other by multiplication and division. So what that means for an expression like this one is we're going to have to factor before we can do any reducing. So I need to factor the numerator, and so I'm going to set up my two parentheses for my reverse FOIL. I know it's going to factor into x and x. I see that I've got a negative 12 here, so I need one positive and one negative since I have to multiply to make a negative number, but I need to add to make a positive. So for my factor pairs, I've got 4 and 3, I've got 6 and 2, I've got 12 and 1, so hopefully it's obvious that it needs to be 4 and 3, with the 4 being positive, so that we end up with a positive 1x out of those two middle terms. Then I'm going to do the same thing on the bottom. So I'm going to set up my parentheses. We know it's x and x. This time we're multiplying to make a positive 12, and we're adding to make a positive in the middle. So that means both of these need to be positive. And again, I'm going to use these same factor pairs. So now I'm looking for a pair of those numbers that adds to make 7. So once again, we're going to use that 4 and 3. And so now that we have it factored, we have these two sets of parentheses in the top and the two sets of parentheses on the bottom that are linked by multiplication. So that means we can go ahead and reduce entire sets of parentheses. So we've got an x plus 4 in the top and in the bottom, so those can be cross-canceled away, they divide out. Now we might be tempted to reduce that x minus 3 over x plus 3. So they both have x's, they both have 3's, but we cannot simplify any farther because they are linked by opposite positive negative signs. So this is the best that we can do here. We cannot cross-cancel the 3's, cannot cross-cancel the x's in that one. In the third example, we're going to do the same sort of thing. We cannot start to reduce until we have factored everything. So up in the numerator, we've got a little undistributing that we're going to be able to do. So we can see that there's a 3 in common between both parts of that numerator. There's also a y that's in common. So I'm going to undistribute a 3y, and I'm going to be left with y plus 7 left behind. And then we're going to have to factor the bottom. Again, although there are 3 parts here, I'm probably going to have to do some reverse FOIL eventually, but I'm first going to factor by undistributing because I can see that everything has a y in common. So I'm going to undistribute that y, and so I'm going to be left with y squared minus 2y minus 63. And so now I've factored completely up in the numerator, but I still have a little work to do in the bottom. So even though I could cross-cancel the y's now, in the top and bottom I'm going to leave them until I'm ready to do all of my cross-canceling reducing. So I'm going to set up my two sets of parentheses here. So I need to find two numbers that multiply to make negative 63 but add to make negative 2. So I know it's y is the first piece in each set of parentheses. I know it's got to be one positive and one negative because we're multiplying to make a negative. And so if we roll through our possible ways to multiply to make 63, hopefully the one that jumps out to us is 9 times 7, since that will help us with that minus 2 in the middle. and then we need the 9 to be the negative because we need the negative number to be larger than the positive number in our factorization. And to be perfectly honest, since I already see that there's a y plus 7 up in the top, it's a good bet that I'm going to have something that's going to be able to reduce with it on the bottom. Not always, but it's more likely than not. So now we can go ahead and do our reducing, and indeed we have those y plus 7s that can go, and then we also have the y on the bottom and on the top that can go as well. So those are all linked by multiplication to all these other pieces, so that's why we're able to reduce that. And so up in the numerator, the only thing we have left is 3. In the denominator, the only thing we have left is y minus 9. And then for the same reasons as on the previous question, as tempting as it is, we cannot reduce that 3 and that 9 because that 9 is connected to the y by subtraction. We cannot cross-cancel reduce things that are connected by addition or subtraction to other terms. We can cross-cancel entire parentheses like we did over here, as long as they're linked by multiplication to other terms in the numerator or denominator, but if we're just linked by subtraction, no can do. Now when we're multiplying or dividing expressions, these rational expressions, it's really just more opportunities for reducing and cross-canceling than if we just have a fraction like we had up above. So in the first example here, again, there's no addition or subtraction, but I do have multiple x's and multiple y's all over the place. We could go ahead and just start reducing stuff straight away, but I think a better approach is to gather up all the variables on the x's and y's in the top and on the bottom and then simplify. It's just way less likely that we're going to lose track of something between the numerator and denominator with all the cross-canceling reducing that we would have to show. But I'm not going to multiply the numbers together. So up in the top I've got 3 times 6. I'm going to leave those separate because I'm just going to end up having to reduce with what's in the denominator anyway. And so then I've got the 12, so I can see where that's headed, but I'm going to leave it as is for now. Now in the numerator, I've got x squared, I've got x to the 4th, so those two are multiplying each other, so I'm going to combine that into x to the 6th. I'm going to add their exponents together. Then I've got y to the 6th and y to the 7th, or y to the 1st, combining to make y to the 7th. Then in the denominator, I've got x to the 3rd, x cubed cubed. So remember, we're going to multiply those exponents. That's going to make x to the 10th. And then I still have another x in the other denominator, so that's going to combine to make x to the 11th. And then I have the solitary y down there, y to the 4th. So I just think this is a little bit cleaner approach so I don't lose track of stuff by just jumping in and reducing right away. But now I'm ready for that. So first of all, I've got 3 times 6 on the top, I've got 12 on the bottom, so I'm going to reduce away the 6, and the 12 here turns into a 2. For the x's, I can see that I have 11 x's on the bottom and 6 x's in the top, so when I reduce those, I'm going to end up with x to the 5th on the bottom, so I'm subtracting the exponents there because we're dividing, and I'm just putting the answer where the larger number was. Then I'm going to do the same thing for the y's. I've got 7 y's in the top, I've got 4 y's in the bottom, so when I subtract those exponents, I'm going to end up with y to the 3rd on the top. So I just don't want to lose track of anything now, so I know I've got that 3 out in front, the 6 is gone, the x to the 6th is gone, now it's down to y to the 3rd, and then in the denominator, I still have the 2 from the 12 when I reduce that, and then I still have x to the 5th. So for the last one, it's a division question. And so remember that we pretty much never divide with fractions. Instead, we multiply by the reciprocal. So I'm going to change this to a multiplication question, but then this second fraction is going to get flipped over. So because we're advanced, I'm going to do a couple things at once here. I'm going to factor all of the expressions that I can in this example, and I'm going to change the problem from division to multiplication by the reciprocal of that second fraction. So the first fraction is not going to get flipped. It's going to stay as is. And so the x minus 2 that's in the numerator, there's nothing I can do with that. In the denominator here, I've got this x squared plus 5x. Hopefully we see that we can undistribute an x. So I'm going to take that out, and I'm left with x plus 5. Now I'm going to change this to multiplication. So I've got a multiplication symbol here, and now I need to factor this second fraction. I'm going to do that at the same time as I'm flipping it. So this denominator here is going to end up in the numerator, and when I look at x squared minus 25, we hopefully recognize that as being a difference of squares. So that's going to factor into x plus 5 times x minus 5. So that's the denominator that's been factored and moved up since we're flipping that fraction. And now we have to do the same sort of thing here, where I'm going to factor it, but it's going to get moved down to the bottom when I flip that fraction. So I can see that there's an x that's in common between those two terms. If I factor out an x, we're left with x minus 2. And so now we've got everything fully factored. So everything in the top, if we kind of think of this as being in a set of parentheses here as well, is linked by multiplication. Same thing true on the bottom. So our cross-canceling bonanza can begin. So we can see hopefully that there's an x minus 2 that's in common in the top and bottom. There's an x plus 5 that's in common in the top and the bottom. But that's it. We've got an x minus 5 that's left up there. We have an x over here. We have an x over here. So together, x times x makes x squared. Of course, we can't cross-cancel those because they're both in the bottom. We just reduce from top to bottom. And so for the same reasons that we outlined earlier, we cannot reduce those x's because that top x is connected by subtraction to the 5. So this is the best that we can do.